Hi, this is my test 2 wrapper, and today I'll be going over question 3, which was the energy graph questions. So for part A, the question asks two electrons which start out some distance apart and at rest, that is, their initial velocities are 0, and we're asked to graph the kinetic, potential, and total energy for the system. So since you know that the two electrons are starting out some distance apart, you know that you can draw a dotted line somewhere around here. And so the two electrons have the same charge, so they're going to want to repel away from each other. So you know that the kinetic energy is going to increase, and so you can sort of draw a graph somewhere along the approximation if you're going away from that dotted line. And then you also know that the potential energy is going to decrease because you have all that potential energy stored up when the electrons are initially near each other. And so you know the potential energy is going to decrease, and it's going to be the exact opposite of the kinetic energy, which is going to be somewhere around here. And then for total energy, since the total energy initially is all potential energy, it starts here. So that you know that it's eventually going to be all kinetic energy, which is here. So you can know that for total energy, you draw a straight line here. So you have total energy, you have your kinetic energy here. Below that, you have your potential energy, so that's your first graph. For part D, it says that a comet approaches the sun from far away, but does not collide or orbit the Earth. So again, you know that you can add a dotted line here because it's approaching from some distance away, so it's not approaching from 0, where the origin is. So since it's approaching the sun, when it's far away, you know the potential energy is going to be low, and kinetic energy is going to be high. So you know the kinetic energy is going to decrease, and potential energy is going to increase as it gets closer and closer. So you have your potential energy here, which is increasing, and it's going to go towards 0. And then you're going to have your kinetic energy, which is going to decrease, which is going to decrease like this. And then for total energy, you know that kinetic and potential energy will never both go to 0, because the comet will never touch or collide with the sun. So that you know your total energy is going to be somewhere around here. So you have your total energy here, kinetic energy, and potential energy. And the last question is E, which says that a spacecraft leaves Mars with an initial velocity that is below the escape speed for Mars. So you know that the spacecraft is going to have to leave with some initial velocity, so it's going to have some minimum amount of energy and distance required to leave the Earth. So again, you can draw a dotted line, and that will be our minimum. And then you also know that it's below the escape speed, so the spacecraft is going to leave Mars and then fall back down to Mars because it's below the escape speed. So you know that there's some sort of dotted line of maximum value, so that will be our max. Then you also know that kinetic energy is going to decrease as the spacecraft leaves the atmosphere. And so kinetic energy, as here and here before, kinetic energy will decrease, but it'll only decrease down to this dotted line here. So that's your kinetic energy. Then you know that your potential energy will increase, but that will increase to 0. So that goes here. And then you also know that your total energy is never going to be positive, it's like kinetic energy, because the spacecraft is never actually leaving the atmosphere of Mars. So you know that the total energy is somewhere along the line of here. That's your total energy. So that's the last problem, and thanks for watching.